Um, this video is going to be called Summer 43, and it's the first video for your Monday class coming up on 17th, on the 20th. And it's about recharge. So recharge is in your book, but what is recharge all about? Well, we've learned over the years that if we pump too much water out of our aquifers, we have all kinds of problems. Um, One of the problems is land subsidence. Let me show you what that's about. Groundwater extraction. That means we're taking groundwater out of the ground, and then we get subsidence. So what's that about? Well, here's a nice picture that can show you what subsidence can do. This photograph was taken in 1977, and you can see that the man is standing here on the ground in 1977, and they also have 1955 marked and 1925 marked on this telephone pole. Well, let's say this guy is 5'7". That means that the ground has sank maybe 18 feet since 1955, and since 1925 it subsided another maybe 30 feet. So why did this place is what we call out in the California wine country, the San Joaquin Valley, and before 1925 there was very few people living in the San Joaquin Valley in California. It was kind of a desert. And then they started to pump the groundwater out of an aquifer underneath the San Joaquin Valley. And look how the ground has just sank. Can you imagine what this sort of ground subsidence would do to buildings? It destroys them. It destroys their foundation. The walls start cracking. The building starts falling apart. So it's a big problem. If you're going to pump groundwater out of the ground, your buildings in the area will be damaged as the ground sinks. It's also going to make sinkholes, which are these holes like this, and this happens all the time in Tennessee, when you take groundwater out of the ground and then you get these sinkholes forming, and parts of roads fall in, houses fall in. So you just can't keep pumping groundwater out. Also, if it goes far enough, you'll drain out the aquifer and you won't have any water left. So what this idea of recharge is oh, let me show you two more examples. Venice in Italy. Everybody knows about Venice in Italy. The city is sinking. Why is it sinking? Because they pumped the groundwater out, and that's caused the entire city to go deeper and deeper into the water. Another place in Italy that you probably want to visit when you go there is the Leaning Tower of Pisa. Why is the Leaning Tower of Pisa leaning? It's ground subsidence. And it's leaning more and more and more. So now they had to spend a couple $1,000,000 to just stabilize the structure. It's because of subsidence. So over the years, we've learned that a fundamental rule is that for every gallon of water you take out of the aquifer, you've got to add a gallon in. So how do we recharge the aquifer? Well, I told you about what we call treated wastewater. One source of water which we can use is treated wastewater, and that means Water that goes down your sink, goes down the sewer grates, goes down your toilet, goes down your bathtub, just gets sent to the local water factory. The water is cleaned by passing it through sand, activated charcoal, and maybe even another couple of yards of sand with bacteria in it that kill the dangerous bacteria. There are friendly bacteria too. Your body is filled with them right now. And then we can, once that water goes through all of those different cleaning processes, then we can use ozone, UV light, or chlorine to kill any bacteria that's left. Then the water's tested, and then that's what we call treated wastewater. And if it meets Safe Drinking Water Act standards, SDWA standards, we can re-inject that water back into the aquifer. And so this shows you, everybody knows about the kind of water well where we extract water or remove water from the aquifer. But there's another type of well where it's called an injection well, where we inject treated wastewater and any water that also gravel pits can be used and to collect water, and that could be collected too. And then we inject the water back into the aquifer, so that for every gallon of water we remove from the aquifer, we add a gallon. And another thing that is an important groundwater problem for coastal people is saltwater intrusion. In other words, take a look at the situation here. Here's the ocean. Here's your freshwater aquifer, and then we put in a well. We're pumping water out. Well, that causes a cone of depression to form. You know that, and that causes saltwater to contaminate our freshwater aquifer. Obviously, saltwater is not drinkable, and that destroys the aquifer if you don't stop this saltwater intrusion. So what coastal people are doing, this is the proper way of managing water resources, is you got to detect any saltwater intrusion into your aquifer if you're along the coastline. If you're inland, like we are in Tennessee, we have to track pollutants and make sure they don't get into the aquifer. And we'll talk about that in a moment. But coastal people have what they learn to do is they have an injection well where they put the treated wastewater in here, and that makes a barrier preventing the salt water from getting into our pumping well or our extraction well. So managing our water supplies is we have to know where all the pollutants are, all the dangers to the aquifer are. We have to make sure that enough water is re-injected back into the aquifer to make up for that which we extract. We have to make sure that the water that comes out of people's sinks meets SDWA standards according to MZLs. And so groundwater is a limited resource. We don't have an unlimited amount of groundwater. We have to and we do it in Anderson County, we do it in Roane County, Morgan County. We have hydrologists who monitor the available amount of fresh water in aquifers, rivers, and lakes. We know how much we need for agriculture, for companies, for people, their households. And then we have to understand the hydrologic cycle so that we can figure out how much water do we need to pump in to the aquifer, and we'll have to make sure that the aquifer is cleaning out the pollutants. And the best aquifers, please don't forget, are sandstones are the best aquifers because they remove many poisons, arsenic, cyanide, and many bacteria as well. Oh, there they got it. They got that photograph there. Okay. So pollution. Let's talk a little bit about pollution. Pollution is a big problem. And there are many sources of pollution that can get into our aquifers. There's pesticides and um, fertilizers that can get in from farms into the aquifer. There's pollution that companies dump into rivers and lakes or into the ground. If you dump it out in the ground, it's going to leak into the water system. It really makes me sick when I see some people go to the Smoky Mountains and dump motor oil out on the side of the road. One pint of motor oil can contaminate 10,000 gallons of water in an aquifer. That's really irresponsible. When you have paints and solvents and dangerous chemicals, you need to bring them into wherever you live and have it taken somewhere so that the city can dispose of it properly. Don't just dump it out because that can contaminate our water supply. Leaking gasoline tanks are big. Um, you've all seen gas stations that have closed down, old gas stations. Well, a lot of them have closed down because their underground gasoline tanks are leaking and they can't afford to put in a new one. We have to make sure that these old gasoline storage tanks underneath gasoline stations don't leak into the water supply. Hospital waste is big. Um, Hospital waste is um, contaminated blood, syringes, um, all the garments and sheets that these people who have coronavirus have. What do you do with them? You have to dispose of them properly. Um, and you don't have to be a Democrat or a Republican to want clean water. Everybody wants clean water. I could really appreciate clean water being from the state of New Jersey, where there's not as much clean water as there is in Tennessee. Growing up, my little sister and I didn't see any ponds and lakes and things like that you see in Tennessee where you go swimming or fishing. We would walk about a mile and a half to go to this little pond that was just maybe 4 or 5 acres, and the other kids would walk to it too. And it was filled with syringes and blood bags and grocery carts. So one of the things I really love about Tennessee is there's actual clean water here because of the I went to first thing I did when I moved to Tennessee is I made some friends, and they took me to Norris Lake, and they said, Arthur, do you want to go swimming in the lake? And I said, no, I'm not going to do that. No. And I realized the water is actually clean here. We want to keep it that way. So, what are the main sources of pollution to the water supply here in Tennessee? The main source of pollution is leaking septic tanks in rural areas. So if you live in a rural area and you have a septic tank and it's leaking, that all that disgusting stuff is going to get into your water. So make sure when you buy a piece of real estate, uh, if you buy in a rural area and there's a septic tank, that you know how old that septic tank is. If that septic tank is more than 30 years old, it has to be replaced. And the seller of the home is not going to tell you that because they want to sell the home. And you've got to pay to put in a new septic tank. But that in Tennessee, in rural areas, is the main source of pollution. Around the country and around the world, one of the biggest problems is landfills. So you pay for landfills in your taxes. And I don't know if you live in Oak Ridge, for example, they come and they pick up your garbage and they dump it in the landfill. And landfills are really disgusting, smelly places sometimes, especially if they're not properly managed. The garbage and the food and all the other stuff in the trash can be 50, 100 feet tall in some of these landfills. And these are breeding grounds for diseases, um, bacteria, mice, rats. Um, can you imagine what's going to happen when it rains on this garbage and that all those poisonous chemicals get into the aquifer? This is a major threat to our water supply. So cities can cut corners and just have buy a large tract of land and dump the garbage there, but then you're going to pay the price in contaminated water. Also, it's going to reduce the cost of real estate values for houses near the landfill. No one wants to live near a landfill. All those smells and all those poisons. Um, Garbage has to be managed in a way so that the public stays safe and that the water supply stays clean. So I'd rather pay more taxes or have the state pay more into a well-designed landfill because it's going to save you more money in the long term. If you have a disgusting, dirty landfill like this, you're going to have higher cancer rates. You're going to have people getting sick. So more and more and more in the United States, um, people are demanding multi-liner landfills. What's that? Well, some areas here in Tennessee, they just dump out the garbage, and that's really bad. But other parts like Oak Ridge, they're doing it right, where they have many different layers separating um, the aquifer from the garbage. And the first layer that they put down is this heavy PVC. It's kind of plastic liner, like this. So you lay out this liner. Then what do? Well, you got so here's your PVC liner. Then you put sandstone or sand here, and then you have a clay, which is a good aqua-clue that stops the movement of contaminants. Then you put in another layer of this metals, and then you have a soil on top. Well, the way this works is when it rains on the garbage, the chemicals that are produced, that's called leachate, they collect in the sand, and then you could put pipes into the sand and collect that leachate, all those noxious chemicals, and then you can have it pumped into barrels. Then the EPA picks up those barrels and finds a suitable disposal site for them, a place where it's not going to get into anybody's water supply. So this is called a multi-liner approach, and wherever you live, I would demand that because if you might save a little bit of money by just dumping the garbage on the ground, but you're going to pay for it in the long run in your health, reduced real estate prices. People don't want to live near all that smell. And what else is a big problem? Well, hospital waste I mentioned, but low-level nuclear waste is a high-level nuclear waste. Low-level nuclear waste is from X-rays and different scientific tests that use radioactive isotopes. But the high-level nuclear waste is the biggest threat to our groundwater supply. High-level nuclear waste. And what is high-level nuclear waste? It's the most dangerous thing that we have. And it comes from the manufacture of nuclear weapons and also from nuclear power plants. Well, high level nuclear waste is so dangerous that back in the 1980s, we um, President Reagan decided that we need to put all of our waste in one place, um, like the rest of the world, and so that's called a central waste repository. Central waste repository. So all the countries in the world have one place where they put their nuclear waste. Why is that? Well, um, Germany puts theirs in the Zechstein salt mines. In Britain, they have a granite on a island where no one lives. Japan puts theirs on Ningiatog Island, another island where no one lives. And there's aqueducts stopping this waste from getting into anybody's water supply. So there are a lot of places that it could be a central place to put the waste. If you put the waste in hundreds of locations around the country, you're going to have all sorts of potential leakage problems. It's harder to monitor. Also, terrorists will want to get at it. Can you imagine what would happen if terrorists put in a bomb in one of our places where we store high-level nuclear waste? It's a security threat. So President Reagan decided in 1980 that we should put everything at Yucca Mountain in Nevada, and I think that was a good idea. Um, Yucca Mountain nuclear waste storage. So Yucca Mountain is out in the desert in Nevada, about 90 miles northeast of Las Vegas. And I know a lot about Yucca Mountain because I was one of the guys working in these tunnels, getting it ready to put our high level nuclear waste. We had a train system put in, a ventilation system put in, and it's 2 miles underground. And we took a train inside there, and we were getting it ready. Why did we pick Yucca Mountain? Well, Yucca Mountain is perfect because Nevada is dry, so you're going to have less rainfall. We put the high-level nuclear waste in these canisters, and they'll rust over time. And we have to keep this. High-level nuclear waste has to be isolated for 100,000 years. That's how dangerous it is. So those canisters are going to rust over the long term. So we need to put them in a dry place, a place with no earthquakes. Yucca Mountain is no earthquakes, and a place where there's nobody close within 50 miles. There's maybe 2,000 people living near this whole area. And it's on government land, so you have less zoning problems. And the rocks are perfect because they're good aqueducts. Even if there was a waste leakage, we could stop it before it got to any aquifer. And unfortunately, this was canceled in about 2007 after we spent $50 billion on the solution, and it was done for political purposes. But I think that this is a big problem now because now we have our nuclear waste stored at hundreds of locations around the country. All of them have to be guarded. We could have easily guarded Yucca Mountain with just maybe 100 Marines. No one, but you could see people from miles away. I don't always agree with Democrats or Republicans getting involved in the politics here, but I think that this was closed. The Democrats put a lot of pressure to close this place down from Nevada Democrats, and I think that they should get out of politics because now we've wasted $100 billion and we have no solution to our nuclear waste problem. Sometimes I disagree with Republicans. Sometimes I disagree with Democrats. In this case, I disagree with the Democrats because it's not good for the country that we shut down Yucca Mountain. Now we have no solution to the problem. Anyway, I'm going to go on to the next chapter. Coastlines. I'm guessing most of you haven't lived near coastlines. I've been interested in coastlines my entire life, growing up in Jersey. My parents used to take us to the Jersey Shore, and I loved going to the beach and going to the boardwalk. And I got my PhD in Southern Cal, and I've been to every beach from the Mexican border to all the way near Vandenberg Air Force Base. So it's about 100 beaches. Um, where the land meets the ocean, we call it a coastline. Or some people, a lot of people back east call it a shoreline. There are three main forces that affect the coastline, including the moving of sediment. And those are waves, currents, and tides. So we're going to talk about these waves, currents, and tides. First one we're going to talk about is waves. If you've been to the ocean, you know it's a lot of fun. If you when you're a parent, your kids can play and make sand castles, and you can sit underneath the umbrella and um, bake in the sun and drink a gin and tonic, and it's just beautiful watching the waves come in. What causes waves? Why do we have waves? Well, simply said, it's wind. Wind makes waves. And here you can see a typical ocean wave. And if in this case the wind is blowing from left to right, the top of the wave is called the crest of the wave. The bottom of the wave is called the trough of the wave. Um, I had a lot of friends who were surfers, and they always wanted to catch the crest of the wave and ride it inshore. It's a lot of fun. The distance between the trough of the wave and the crest of the wave, measured in feet or meters, is called the wave height. Obviously, a 20-foot high wave is going to be a big wave, right? And a 3-foot wave would be a small wave. The distance between crests is called the wave length. Okay, those are the two main ones you got to know right now. What wave height and wave length is. Try and imagine your mind instead of just memorizing it. Imagine the waves coming into the shore. If the waves are all bunched together, then the wave length is very small, very short, right? If there's a long time that occurs between waves hitting the shore, then you get a long wavelength. Now we want to talk about swell. Ocean swell. What is swell? Well, swell is where waves begin in the deep ocean. And in the deep ocean, you have ocean swell. For ocean swell, wavelengths are very long and wave heights are very short. If you've ever been on a cruise ship, you know what ocean swell feels like. Ocean swell, you know, you're sitting in the you're standing there in the cruise ship, maybe in the dining room, or maybe in the casino or wherever, and the ground moves. The boat moves up maybe half an inch, very little, but you can still feel it, and then it goes down, and then maybe it takes a long while, maybe 20, 30 seconds later, it moves up again and down. So that's what makes people seasick because they're not used to that. But long wavelengths, short wave heights are associated with deep ocean swell. As the waves approach the shoreline, let me see. I'll probably get a better picture of this for you online. Okay, let's take a look and see what happens when waves approach the shore. So here in the deep ocean, you got longer wavelengths and smaller wave heights. Now, the next thing we need to learn about is this dashed line. That's called wave base, BASE, wave base. And wave base is equal to 1/2 of a wavelength. What is wave base? Well, in order to understand what wave base is, we have to understand how waves move and how the water within a wave moves. If you just sit on the shoreline and you watch the waves move in, it almost looks like the water is moving from offshore and then it's crashing inshore. That's the way it looks, right? But actually, the individual water molecules are moving in circles like this. That's called oscillatory motion. So the individual water molecules are moving in circles, even though it looks like they're moving towards the shore. The waves are moving on shore. The waves of energy are moving on shore, but the individual water molecules are moving in a circle. That's why when a surfer goes out into deeper water and he loses his surfboard, it doesn't just move to the shore, it moves in a circle. Well, the best way I can say that is think about a football stadium at UT, and the fans stand up and they sit down in sequence, so it looks like to make a wave, but it looks like a wave of students moving across the stadium, but really what the students are really doing is just standing up and sitting down in sequence, right? Or imagine a field of grain, and the wind is blowing. It looks, you can see the waves. The stalks of grain are not running across the field; they're just bending back and forth. Same thing with the water in a wave. It's moving in circles, but it gives that appearance that the individual water molecules are moving towards the shore when they're just moving in circles. Okay, having said that, these circles get smaller and smaller the deeper you go into the water. So water molecules down here are moving in a tiny circle, whereas the bigger circles up near the top of the crest. This dashed line is called wave base, equal to 1/2 a wavelength, and wave base is the depth of water where the water is no longer moved by the wave. I'll repeat that. The wave base is how deep you need to go to no longer be affected by that wave. Okay, if you like swimming, you know what wave base is. I love to swim. So if you're at the shore, if I swim deep enough underwater, I can't even feel the wave moving over me, right? I've swam underneath wave base. Did that make sense? Okay, so deep water or swell, ocean swell has long wavelengths and short wave heights. But once wave base intersects with the ocean bottom, things change. Because then the bottom of the wave is going to experience friction, whereas the top of the wave won't, right? So the bottom of the wave is going to slow down and the top of the wave is going to keep moving. Therefore, the waves are going to get higher and higher. And the wavelengths will be shorter and shorter. The waves are going to get bunched up as they approach the shore, like cars in a traffic jam. As everything slows down, then the crests get closer, right? So as waves approach the shore, please remember, wave height increases and wavelength decreases. Finally, the waves get so high that they cannot support themselves, and that's when the waves break. When the waves break, you're in the surf zone. So after the waves, when the wave height gets so high that the wave can't support itself, the waves break and you're in the surf zone. Here you can see another picture showing it. Here's the wave, here's the swell, and then the waves get higher and the wavelengths get shorter. Finally, the waves get so high that they break. After they break, so where they break is the surf zone, but then the last bit before you hit the beach is the swash zone. SWASH. What's a swash zone? Once you're in the swash, that's after the waves break. Um, um, that means the water is just going to move up the beach face and move back down. So the water no longer is moving in circles. It's going to move straight down the beach face and back up. Straight down the beach face and back up. Back up. So if you've been to the beach, you know that place. That's where kids build their sandcastles. And you can see the water just moving up the beach face and then moving back out towards the ocean and moving back in and moving back out. That means you're in the swash zone. Swell over here, surf, and then swash right next to the shoreline. Okay, we'll do more in the next video.